Greetings, math fans. All right, so this is day 10, and on day 9 we actually talked about absolute value equations. Now we're going to talk about absolute value inequality. So absolute value inequalities. Okay, absolute value inequalities. So basically, there are two types of absolute value inequalities. All right, and I'm going to start with some really basic ones, and then we're going to get to just a little more aggressive ones where you have to solve a little bit more. Okay, so basically, you can either have absolute value of x, and I'm going to make this in bright, so is greater than, we'll say, 3. And then the other one is absolute value of x is less than 3. Okay, those are the two types. So you're either going to have a greater than symbol or a less than symbol. First of all, let's talk about what each of these are. So this first one with the greater than 3, we call this an OR problem. All right, and the way you can remember that is this symbol right here is a greater or problem. So this is an OR problem. Got to remember that. If it's a greater than symbol, it's an OR problem. Okay? If it's a less than symbol, we're going to call this a between problem. Got to remember that. That's the first thing you got to know. Okay? So if it's a greater than symbol, it's a greater. So it's OR. It's an OR problem. If it's less than, then it's a between problem. Okay? All right. So let's talk about how you actually go ahead and set this thing up. Okay, so what I'm going to tell you for the first one is identical to every single problem you're going to set up, except again, things get a little more complicated. But here's the deal: you are going to say, in this, so here, x is less than. So I'm going to actually put this in bold green. X is less than. Okay, negative, and now I'm going to put this back in black, negative 3. So that value, but it's negative 3. Okay? And I'm going to put this again in bold because this is always the case. Or x is, put this in bold again, greater than, I'm going to put this as positive, though you don't write positive, positive 3. Okay? So let's just write it out nicely. So x is less than negative 3 or x is greater than positive 3. This is what goes in the answer blank. And then you need to graph it. So the graph, by the way, I'm going to put, before I even graph this, every graph that looks like an OR, every single graph will look like this. So I'm going to put this in green again because this is always going to look like this. You're going to make a graph and you're going to graph 2 points like this, and in this case here it's going to be these are open dots, and it's going to point this way and this way. Think of a boat, right? If you go on a boat and you're fishing and you have some oars, right? You oars. So if you have oars, don't those oars point out when you're fishing? So you're like row your boat, right? You're rowing. So that's why this one you can kind of remember those point out like that. All right, so let's go ahead and write the answer to this one. So I'm going to draw a number line here, and I'm going to put negative 3 and positive 3, and I'm going to draw the arrows. And that's my answer. So this, let me highlight this here in blue. Okay, this, math fans, that's gray, I guess. That is my answer to this problem. Okay? So we're going to do a bunch of these problems, but if it's an OR problem, that's what it's going to look like. Okay, so again, just to kind of highlight this, this is an OR problem. So this is what you're going to do. You're going to say x is less than negative of that 3, or x is greater than positive of that 3, of that number. Okay, and that goes in the answer blank, and then you draw a graph. They look like ORs. The negative 3 is on the left and the positive 3 is on the right, and you draw the arrows pointing opposite ways, and that's your answer. Okay? All right, so that's an OR. And again, we're going to do a couple examples here in a second, okay? But I want to get to now the between problem, which is very simple as well. First of all, you are going to write out this. Let's do this in black. So you're going to say x, and I'm going to put this in kind of bold green again because this is kind of always the case. So x is, and these arrows always go that way. Always, always, always point to the left. That's how a between problem is. You'll never see a between problem where it points the other way. Okay? And what you're going to do is you're going to say negative of that 3 and positive of that 3. Okay? And as I kind of did with this guy right here, you know how I kind of showed you real quickly what it's going to look like? Well, if I did that the same thing with between problems, this problem is always, always, always going to look like this. Got those two values? It's always going to be a barbell. Always, always, always. Between problems are always barbells. Okay, so if I go ahead and graph this one now, by the way, this is my solution that I put in the answer blank. Let's make it a little bit better, a little cleaner. Negative 3 less than x less than positive 3. Okay? So then on your answer blank for the number line, you're going to put negative 3 and positive 3, and you're going to put a barbell. And that's it. So again, if I highlight what the solution is, this, oops, I'm kind of cutting off there. This is your solution for that problem. Okay, so x is between negative 3 and positive 3. That's for a less than problem. A great or is an or problem, and you write it out like the left. So this is like the simplest thing I can give you is just hand you that. And now let's do a couple more challenging problems, but they're not bad. You just have to know how to solve for x, basically. Okay, so let's kind of start out here. And if I said, what can we say? Well, let's say 2x plus 1, the absolute value of that is greater than, let's say, 7. Okay? The first thing you're going to recognize is you're going to go, oh, look at that. I've got a greater than symbol. So as soon as you see great or, you know it's an or problem. So I'm going to write here in red, this is an or problem. Okay, so I know my answer is going to look like this. I just know it is. I know it's going to look like some values. It's greater than, so it's an open dot. It's going to look like this and like this. I know it is. Okay, I just need to fill in those numbers, and that's what I'm going to figure out. So remember what I told you. It's 2x plus 1 is less than the negative of that, so less than negative 7, or 2x plus 1 is greater than positive 7. Got to remember that. It's less than negative of that number and greater than positive of that number. Okay? And then you solve. Okay, each of these. So you subtract 1 from both sides, so you get 2x is less than negative 8. Divide by 2. X is less than negative 4. This one I subtract 1 from both sides, so 2x is greater than 6. Divide by 2. X is greater than 3. So I'm going to put an or in the middle, and this was what goes in the answer blank. X is less than 4, or negative 4, or x is greater than 3. So see this little graph that I did over here on the right-hand side? You are going to write a negative 4 here, and you are going to write a 3 here, and you are done with the problem. Okay? So this part right here is the solution written in algebraic form, and this part right here is written in as a graph. And that's it. You're done with that problem. Okay? All right. So let's try another one here. Let's do absolute value of 3x minus 2 is less than or equal to 13. Okay? So the first thing we're going to do is you got to look at the inequality, and the inequality is less than or equal to. So it's a less than or equal to. You got to remember this is a barbell, so this is a between problem. Between. Which means my final answer is going to look like this. In graph form, it's going to have something like that, and since this is less than or equal to, it's going to be solid dots, and that's it. it's going to look like that. Okay? So, if you remember the setup, I'm going to do 3x minus 2. They always point this way. Always, always, always. And we're going to put a negative 13, so negative of this number, and a positive of this number. Okay? And so what we're going to do is now, if you guys remember, we're going to add 2 to all sides to solve for that middle. And we get negative 11 less than or equal to 3x less than or equal to 15. Okay, and then we're going to solve for x. I'm going to divide everything by 3. Now that left side is a little nasty, but that's okay. And I don't care how you leave it. If you leave it as negative 11 thirds, but your final answer is going to be negative 11 thirds is less than or equal to x is less than or equal to 15 over 3 is 5. So this is your answer, and negative 11 thirds and 5. That goes on the answer blank, and you are done with the problem. So again, here's your answer that you're putting on the answer blank, and here is the graph. Okay? That's it, guys. It's really not difficult. You just have to study it and practice it. Okay? So let's do a couple more more difficult ones. And again, it's not like super difficult, but it has a little bit more to it. So if I said 1 plus 2 absolute value of x minus 3, close absolute value, is less than or equal to 7. Okay, so the deal is, right now, a lot of you guys are looking at this less than or equal to, and you're saying, oh, it's less than or equal to, so it must be a between problem. Okay, actually it is a between problem, but you have to first isolate. Once you isolate this absolute value, then you can determine whether or not it's a less than or greater than, because you may have to divide by a negative and then flip it. Okay, then it changes it. Okay, and that'll be our last example. Okay, but let's just kind of keep going with this. Remember, please do not do 1 plus 2. If you add these together, that is like horrible math, and you'll get it wrong. Okay, so what we need to do is subtract 1 from both sides. Okay, so we get 2 absolute value of x minus 3 is less than or equal to 6. All right, and then we're going to divide by 2 because we need to isolate the absolute value, just like we do with equalities. We divide and we get absolute value of x minus 3 is less than or equal to 3. Okay, now you decide. What do we have here? Well, I have a less than or equal to, so that's a between problem. If it's grade TOR, it's an OR problem. So this is a between problem, so you are going to write this out as, first of all, the graph is going to look like this. It's between, so something, and it's solid, and solid, and that's what it's going to look like. Okay, so let's set this up. X minus 3, they always point to the left like this, and you're going to put a negative of that 3 in there and a positive of that 3 in there, and we're going to solve for x. So I'm going to add 3 to all sides, and I get 0 less than or equal to x less than or equal to 6. So I'm going to put a 0 and a 6 here, and I'm done with the problem. So this is, again, my solution is my graph right here, okay, and that. So that's my solution. It's between 0 and 6, and then the graph is a barbell. Okay, it's not bad, right? Okay, let's try another one here. 2 minus, or say 2 plus 2 absolute value of 2x minus 3, close the absolute value, is greater than, we'll go with 14. Okay? So again, you can't tell me right away that this is an OR problem or a between problem, because we need to solve for the absolute value first. Okay? So the first thing I'm going to do, please again, don't do 2 plus 2. You are going to subtract 2 from both sides. So we get 2 absolute value of 2x minus 3 is greater than 12. Okay? Divide both sides by 2. So we get absolute value of 2x minus 3 is greater than 6. Okay, so a great OR. So we know it's an OR problem. We know it's an OR problem. So I know my graph is going to look like this. Something, something, and it's an open dot this time. So it's going to look like that and like that. I know it's going to look like that. I just need to solve it now. So remember how to solve it. You're going to say 2x minus 3 is less than negative 6, or 2x minus 3 is greater than positive 6. That's the setup for that. Okay? Can't do anything different, man. It's less than negative and greater than positive, and then you solve. So it's a little tight over here, but so we add 3 to both sides, so we get 2x is less than negative 3 and divide by 2. So x is less than negative 3 halves. So what? It's a fraction. I don't care if you give it to me as negative 3 halves, negative 1.5, negative 1.5. It really doesn't matter to me. Okay? And then I'm going to add 3 to this one. So I get 2x equals 9 and divide by 2. So x is 9 halves. Okay? So that's it. And I'm going to put an oh wait, I shouldn't say equals. Sorry. It's greater than. And this is greater than. Okay? And this is your answer, math fans. That's what you're going to put in the answer blank. And then this is an OR problem. So again, just like this I did on the top right here, I can write negative 3 halves, and I'm going to write 9 halves, and we're done with the problem. So once again, this is our solution for graph. Okay, and this is our solution for the algebra part. Okay? So let me give you one more that kind of makes it a little complicated, but this is as complicated usually as it gets. Okay, just got to remember, if it's a greater than problem, it's an OR. That means they're going to be pointing opposite ways, and I told you how to set that up already. And if it's a less than problem, it's a between, and you set it up. There's a different way to set that up as well. Got to know how to do that. Okay, if you don't know how to do that, you're not going to get any of these problems right. Okay? Okay, so for my last problem, this is what I'm going to do. I'm going to give you a good problem here, and so it's going to be 2 minus absolute value of x minus 4, close the absolute value, is greater than or equal to negative 10. Okay? So please do not look at this and go, hey, this is an OR problem because it's a great OR symbol. We need to isolate the absolute value first before you can make the decision. So the first thing I'm going to do is I'm going to subtract 2 from both sides. So you get negative of the absolute value of x minus 4 is greater than or equal to negative 12. All right, I got a negative in front of there, so I'm going to divide that whole thing by. Please do not distribute that negative. That's bad. Do not touch inside that absolute value. So I'm going to divide everything by negative 1. I'm going to get absolute value of x minus 4. And then what happens when you divide by negative? You flip around that inequality sign, and we get 12. Okay, now it's isolated, and now you look at this right here, and this is a less than or equal to. So what is this? It's a between problem. Okay, so it's between. So I'm going to set this up right away. I'm going to do the graph at least. Watch this. It's solid dots, so I'm going to make solid dots, and it's between, so it's a barbell. There you go. I know it's going to look like that. So what we're going to do is we're going to set up as x minus 4. They both point to the left like that, and I'm going to put negative 12 here and positive 12. And I'm going to solve for x. So I'm going to add 4 to both, or to all sides. So I get negative 8 less than x less than 16. That's it. And then so I'm going to put, here it is, negative 8 and 16. It's between negative 8 and 16. And so again, this is my answer for the graph, and this is my answer for the equation. And I'm done with the problem. Okay? So please identify whether it's a between problem, which means it's a less than, or a greater, which is an or problem. Make sure you distinguish between the two before you make any graph. But like I said, you need to isolate that absolute value first, just like we did here. You need to isolate this guy right here, and then you make the decision on what to do. Okay? So that's it, math fans. This is absolute value inequalities, and like I said, as long as you follow those steps, you are good to go. All right? That's it. Have an outstanding day, math fans. Adios. Goodbye.